We're on to day 4 now of this area unit. And what this topic covers today is area of shaded regions. And we kind of dug a little bit into that on day 3 with the circles, finding the area of the shaded region left over when I take circles out. So first, what I want to start off today is, how do you find an area of a figure you're not familiar with? Okay, I call these composite figures. All right, called a composite figure. So if you look at number 1, I'm not really too sure what that is. All right, if you look at 1A and 1B right now, and if you go down to 1C, I'm not really too sure what those are. All right, so I don't have an exact area formula for them, but any composite figure, what I can do is I can break it up into figures that I do know the area for. All right, so if we take a look at letter A here, I can take this composite figure, which I don't have an area formula for, but I can break it up maybe into a trapezoid on top and a rectangle on the bottom. What's beautiful about these is that's not the only way I could break it up. I could also break this up into a rectangle on the left and a trapezoid on the right. Okay, and that's actually how I'm going to do this problem. But any ways you can break it up into shapes that you do know the area formula for, that's your best bet. Okay, that's your best bet. So what I'm going to do here, I'm going to leave my green line right there. And the area of this whole thing is going to be the area of the rectangle plus the area of the trapezoid. Okay, and going through our formulas again, I got length times width plus 1/2 height, base 1 plus base 2. All right, here we go. Rectangle, I know I got 12 by, now look, if that part's 8, this part is 8, which is meaning the rest of it here is 7. That green line I just put in has to be 12. All right, so let's continue on. So the rectangle is 12 by 8 plus 1/2. The height of that trapezoid, remember, is the perpendicular line from a vertice, which would be 7 in our case. And the two bases are parallel, which would be 5, which was given, and 12, which I found from the rectangle. Okay, so I broke this figure up into a trapezoid and a rectangle, and I ended up with, if I do the quick math, and it says round to the nearest tenth if necessary, 155.5 square inches. Okay, if one line's not good enough, you can always draw in more. Hey, if that wasn't good enough, I could also draw in this red line here, and now I have 2 rectangles and a triangle. Okay, fine. All right, whatever gets the job done. It just doesn't have to necessarily be 2 figures. Like, for instance, part B. All right, so what can I draw? What line can I draw in so that there's figures I'm familiar with? Well, I already have a half circle here over to the right. If I draw in another altitude here, now I have 3 figures I am familiar with. I have the triangle. I have the rectangle in the middle. And then I have a half circle to the right. Okay, so now I can go 1/2 base times height for the triangle, length times width for the rectangle, 1/2 pi r squared for the circle. Now I just got to find those values out. All right, now I just got to figure out those values. All right, so let's take a look here. Let's see what we got going. Can I fill in any other measurements on this composite figure? All right, well, if that was 22, the opposite side of the rectangle has to be 22. Let's see, the whole thing was 31, so I'm going to have 9 left over here to make 31. How about that blue height I just drew in? How am I going to be able to find that? Pythagorean theorem. So let's do that off to the side right here. I got 9 squared plus my missing side, I'll call b squared, equals 15, the hypotenuse squared. You guys go through that. B is equal to 12. So I got 12, which means over here is going to be 12 as well. All right, I think we got enough info to fill everything in here. Let's see. So let's go to the triangle. 1/2 base times height. Hey, it's a right triangle. We've been talking all darn unit. The base and the height of a right triangle are the legs, which are 9 and 12 here. Let's go to the rectangle. The dimensions are 12 by 22. Oops. go. 12 by 22 plus the circle. Ready? 1/2 pi. How about the radius here? Well, the 12's not the radius. If you see here, 12 is the whole diameter. So I got to cut that bad boy in half and say 6 squared. All right, so that is how I'm getting to the area of this figure. Crunching the numbers on my calculator, I end up with 374.5 square centimeters. All right. Okay, so we just went through 2 there. I'm going to leave you to part C right now. All right, which looks like, and you can assume that this is a right angle, it looks like they did all the work for you as far as cutting it up. So I'm going to let you guys find the total area. Go ahead and get after it. And here's what we're looking at. 953.1. Yeah, didn't really have to do much here. There wasn't any Pythagorean theorem. The only thing you guys had to do was make sure you cut that 16 in half to get to the radius of the full circle. All right, hopefully you guys noticed that there are 2 half circles, make a full circle there. So there was no need to take half of anything. You were just doing the area of a full circle. All right, so 953 square feet. All right, let's go on to some different type problems to finish it up here. D now. Now I'm looking for the area of that shaded region right now. It's telling me that math, M-A-T-H, is a rectangle, and they're giving me some other values, which I should probably write down now. GB is 4.6. MH is 6. HT is 15. And I think what's the area of MB? Okay, so they're asking for the area of that shaded region. All right, so let's make a plan first before we write down any numbers. The area of that shaded region is going to be the area of the rectangle, the whole thing, minus what's the unshaded part? That's a triangle. All right, so we're going to do length times width minus 1/2 base times height. All right, here we go. Length and the width was given 6 times 15 minus 1/2. All right, kids struggle with this one. Every year they struggle. You guys tell me here, what's the base and the height of that triangle right there? MBA, let me highlight it here. There's no need. Some kids every year try to take the 2 triangles separately because there's 2 right triangles that make up MBA, but you don't need to here. All right. What's the area of that full triangle right there? Well, guys, what's the 4.6 giving you? It's drawn from a vertice perpendicular down to G. That's the height. All right. That's the height of that triangle. It's already done, 4.6. And it's drawn to a base of how long? Well, how long's MA? It's the opposite side of a rectangle where that other side is 15. All right, gets kids every year. They don't look at the whole triangle. They look at the 2 right triangles, but no, you don't need to. I'm given the base and the height already of the full triangle MBA. So now I'm on my way. Crunch the numbers and it ends up being 55.5. Which would be choice 2. Okay, so just don't overlook that. All right, don't take it too much farther than it needs to go. All right, here we go. Another tough one, part E. Diagram below. Oh boy. Hey, haven't seen that word in a while. Let's just review real quick. Anybody remember the circumference formula for a circle? Pi times its diameter. All right. Of circle O is 16 pi. The length of BC is 3/4 of the length of diameter AD. CE is 4. Calculate the area of the trapezoid. All right, got it. So they want me to calculate the area of the trapezoid, which I know is 1/2 height, B1 plus B2, the bases added together. They tell me the height already, so I can plug that in as 4. What we need to work with is what's the bases? Okay, what are the bases? Well, I know BC is 3/4 the length of diameter AD. But I don't want to, I don't want to call, for instance, I don't want to call this one X and this one 3/4 X and try to plug it into the formula down here, because now you're not finding the area. Okay. You're just finding something with an X in it. All right. That X isn't going to go anywhere. So I don't want to pull that right now. But I can maybe use this circumference fact to my advantage. It says the circumference is 16 pi equals pi d. Is there something we can solve for? You're darn right there is. I can solve for the diameter, right? I can solve for the full diameter by dividing out this pi. So the diameter is 16, which is also one of the bases of the trapezoid. Now, how to find the other base? Remember, we just talked about it. It's 3/4, right? So BC is going to be 16 times 3/4, which ends up being 12. Now that's the other base, which is 12, and now I'm on my way. All right, so we had to dig up an old formula from last unit, circumference, that would help us find those bases. And the area, once you crunch the numbers, would be 56 square inches. Okay? All right, guys, you got 2 pages here from your packet using composite figures. You're going to have to use some money, it looks like, here at the end. A big 4 problems here. All right, I'm not laying it on thick. All right, 4 problems. We can get through it. Let's get going. Good luck, guys.